In this video, I'm going to solve a problem from chapter 6 assignments for the homework. Given the following augmented matrix, which represents a linear system. Now we are asking to solve the linear system for x, y, and z. So usually we want to write this matrix back to the reduced row echelon form. So we are trying to write the diagonal line to be number 1 and then everything else to have number 0. Okay, so first thing is, let me try to make this location to be 0. So what I can do now is I can multiply by 3 to the first row and then I add it to this row. Let's do that. When I multiply by 3 on my first row, 3 times 1 is 3. 3 plus 4 minus 3, so that becomes 0. 3 times minus 1 is minus 3. Minus 3 plus 1 is minus 2. And 3 times 0 is 0. 0 plus 6 is always 6. And 3 times negative 3, that is negative 9. Negative 9 plus 1 is negative 8. Okay, and then I also want to make this one to be 0, right? So because at the end of the day you want 1, 1, 1, and then the rest you want 0, like that. Okay, for this portion you want all the 1 here, and then you want everything else to be 0, and that is the reduced row echelon form. So I have 1 0 here. Now I want this one to be 0 as well. So I take the first row, I multiply by negative 2. Negative 2 times 1 is negative 2. Negative 2 add to plus 2, that is 0. Negative 2 times negative 1, that is 2. 2 plus negative 1 is 1. And negative 2 times 0 is 0. 0 plus negative 3 is still negative 3. Negative 2 times negative 3 is plus 6. Plus 6 subtract 2, that is plus 4. And then because the first row I already had number 1, so I just rewrite it like that. Alright, so now I have 1 0 0, and I have 1 here as well, right? So the next thing is I want to make this location to be 0. So what I can do now next is I take my second row, I multiply by 2, because 2 here add to negative 2 will be 0. So 2 times 0 is 0. 0 plus 0 is 0. 2 times 1 is 2. 2 minus 2 plus minus 2, that is 0. And 2 times minus 3 is minus 6. Minus 6 plus 0, and that is also 0. And then 2 times 4 is 8. 8 plus minus 8, and that is also 0. And then I'm just gonna rewrite my second row here. 0 1 negative 3 4 1 negative 1 0 negative 3. Okay, in this case somehow we just cancel number 1 here as well for some reason, but let's keep moving on. That is okay to have 0. If it just cancel out by itself, then that is okay. Now next thing is you want to make the 0 for this guy here, right? So how do I make the 0 for this guy? Wow, you see that there's nothing we can really do, because in order to make this guy to be 0, you have to borrow either the first row or the last row. But then you see that there's a 0 here, there's 0 here, so no matter what I multiply to the first row or the second row, the third row, I still have 0, because anything multiplied with 0 is 0. And the 0 add to negative 3 it's just negative 3. So no way that I can change negative 3 to another number. So nothing I can do with negative 3. So that's okay. If we cannot do it, then just leave it that way. Now the next thing is I'm trying to make this one to be 0. Yes, I can do that by adding directly to the second row. So let's do that. When I take the second row, I add to the first row. 0 add to 1 is still 1. 1 add to -1 is 0. -3 add to 0 is -3. And 4 add to -3, that is 1. And then I'm just rewriting here. 0, 1, -3, 4, 0, 0, 0, 0. Okay, and then lastly, I think we are ready to write a solution. Now, because you see that the last row all disappear. So it's telling you that we have what? We have nothing for the last row, which is 0x plus 0. Remember, this is x, this is y, this is z, right? So when you write this coefficient back to the equations, we get what? We get 0x plus 0y plus 0z equals 0. So in this case, if the last row has all the 0, it means that this matrix has infinite number of solutions. And if you have infinite number of solutions, then you can express the solution in terms of z as the parameter. So everything here we can express that in terms of z as the parameter z right here. So how do I express that? Well, let's take a look at the second row. The second row. Okay, let's focus on the second row right here. I know that this is 0x plus 1y minus 3z equal 4. Because you want to express everything in terms of z due to the infinite number of solutions. So now you see that this is no x here, but I have 1y minus 3z equal 4, and therefore to solve for y, I add 3z on both sides. So 4 plus 3z. So this is my y. So the y answer here should be 4 plus 3z, and that is the solution for y, because everything is in terms of z. This equations, the equation that you got here, 0 equals 0, right? You get the statement of 0 equals 0, and this is the true statement. Anytime you have a true statement, you have an infinite number of solutions, and that's why z could be anything. So you are writing the solution in terms of z. So lastly, we are looking for the value of x by looking at the first row, and I can write the first row here. This is 1x, right? 1x plus 0y minus 3z equal 1. So I don't care about y because that's 0. So we have x minus 3z equal 1, and therefore adding 3z on both sides, x equal 3z plus 1. So x is in terms of z, which is 3z plus 1. So your x should be 3z plus 1. And you see that z is equal to z, and then x and y, they are in terms of z. And that is how you got the system of equations with infinite number of solutions.